Welcome to today's session. So today our function of interest is the future value function in Excel. So this function is one of the most used functions in the financial space of Excel. So the function basically helps us to calculate the future value of our investment today. So if we invest some amount today, by the end of the period, how much are we going to have? So if you look at the function itself in Excel, it has got 5 inputs. So the first one is the interest rate per period. So that period can be per month, can be per quarter, can be per semi-annual, or can be per year. Then we have NPER, which is basically a total number of payment periods. So this is the aggregate within our investment horizon. What's the total number of payment periods? Then next we have the PMT, which is basically the payment. So if we are making given payments, could be annuity, could be monthly contribution. So how much is that value that we are making, which is the PMT or the payment? Then we have PV, which is the present value. What's the value of our investment today? So if we invest this amount, how much is it worth today, which we expect to grow to a given amount in the future? Then we have type. So the type basically try to answer the question, at what point do we earn interest? Are we earning returns at the end of the period or at the beginning of each payment period? So if it's at the end of each payment period, we put a 0, which is the default. If it's at the beginning, we use a 1, which is rarely used. Okay, so now what is important to note is if you have PMT, then PV becomes an option. If we have PV, then PMT becomes an option. We may leave it as long as we have PV. But if you don't have PV, then PMT should be provided. Okay, then if we leave type, then it will go with the default, which is a 0, which is we earn interest at the end of the period. So for us to appreciate or not to use this function, let us look at an example. So our example reads, calculate the exact amount that you can have at the end of each term from each of the case below. Okay, so we have case 1, where the annual rate is 12.5%, then the present value is 20, then similarly here is the same, then we have the tenure or the term is 3 years, then the compounding is 12. But this one we have an extra contribution, which is the annuity, which is this payment. So let us find the future value with case 1. So plus equals then FV, we have that, the future value. Then we have the annual rate, which we need to convert to monthly because the compounding is 12 times. So we divide by 12 to get the monthly rate. Okay, then the period number of payment, it will be 3 years multiplied by the number of compounding, which is 12. Then are we making any payment, monthly payment during the time we are compounding? No, so we leave it blank. So how much are we investing? We are investing, the present value is 20,000 kwacha. So since it's an outflow, we are investing, so we enter it as a negative. Then want to earn interest at the end of the period. So we use a 0, then press enter. So at the end of the period, you are getting a 29,043.4 kwacha. Okay, at the end of the period, which is the future value. Then what if we added an extra 100 kwacha every month, which is annuity because they are equal payment throughout the 3 years of investment? How much will be our value? So the future value now becomes the interest rate, which is annual, we divide by the number of compounding, which is monthly. The number of period is 3 times the number of compounding. number of times we are compounding in a year, then we are making this payment. So this payment is an outflow because it's us, we are giving out that money, then the negative. Then what's the present value? So the present value is a 20,000 kwacha, which is also entered as a negative. Then we are want to be earning interest at the end of the period, which is a standard way. Press enter like that. So in this case, we are earning a 33,384.3 kwacha. So the difference that an extra 100 kwacha makes is an additional 4,840.9 kwacha at the end of our tenure. So if you said instead of putting 100 kwacha, let us be putting a 250 kwacha. Then we have a growth. Okay, the difference by 10,852.1 kwacha. That's what this extra 150 can do to our investment. Okay, so if we remove this 20,000 kwacha at the beginning, this one becomes a 0, then we'll still be able to get a 10,000 kwacha 852, okay, 0.1, because we have a monthly contribution. So if you take back a 10,000 kwacha, instead of putting 20,000 kwacha, we put a 10,000 kwacha at the beginning, we'll still get a 25,373.8. So this is basically how the function works. So instead, if you put a 15,000 kwacha, we get a 32. If you change the number of compounding, instead we use a 6 instead of 12, which is every 2 months, let us say maybe twice in a year, our money drops because we are compounding less. So our future value will still drop. Even if you take it back to 20,000 kwacha, it doesn't grow faster than this one where we are compounding. Okay, so let us take it back to 12 like that. So basically, this is how you use the future value function in Excel.